In this video, we'll discuss root locus rule number 4 and remaining rules. So generally, number of poles are more than number of zeros, and in such case, p minus z branches will approach to infinity. So in the beginning, I told that the root locus branches will start from poles and it will end at 0. Or some root locus branches will start from poles and it will end at infinity. It will approach to infinity. So here in rule number 4, we are going to identify how it will approach to infinity. Who will guide those roots to approach to infinity? How it will, in what path it will reach to infinity. So thus this rule gives us information about how these branches approach to infinity. The branches which are approaching to infinity do so along the right straight lines called asymptotes of the root locus. Asymptotes are the guidelines for the branches approaching to infinity. So angles of such asymptotes are given by. So these asymptotes are the guidelines for the roots to approach to infinity. So how to find out these asymptotes? So that is based on angles. So angles are identified by or calculated by theta is equal to 2q plus 1 into 180 degree divided by q p minus z. Here p is the number of pole, number of z is number of 0, and q is varies from 0, 1, 2, 3, and so on up to p minus z minus 1. So these asymptotes are always symmetrically located about real axis. We'll see the example later. In the rule number 5, so now I told that in rule number 4, asymptotes are there, or it is called a straight line that will guide the roots to approach to infinity. Now this where I have to draw these asymptotes, in which point on the real axis. So that point will be given by rule number 5. So that a point is called as centroid. So now only the angles of asymptotes are not sufficient, but where the asymptotes are located in S plane is equally important. Location of asymptotes in S plane is given by this rule. All the asymptotes intersect the real axis at a common point is called as centroid, denoted by sigma. The coordinates of this centroid are calculated as sigma is equal to summation real parts of the poles of g of s h of s minus summation real parts of zeros of g of s h of s whole divided by p minus z. Okay, the key point is centroid is always real. It may be located on negative or positive real axis. It may or may not be a part of root locus. That is very important. See, you will get by using this formula, we will get centroid that point. It may be this centroid is always real because only we are calculating real part of poles and zeros. Okay, we are writing and we are simplifying, and it may exist negative real axis or a positive real axis x-axis, and it may exist on root locus branch or may not. Okay, these are the important points. So now we'll see example for this rule number 4 and 5. So we'll see example. Consider g of s h of s is equal to k divided by s plus 1 s plus 2 plus 2j into s plus 2 minus j2. Calculate angle of asymptotes and centroid. Only this example will describe rule number 4 and 5. See now here number of in the denominator roots are there. One is s is equal to minus 1, s is equal to minus 2 minus j2, and s is equal to minus 2 plus j2. Numerator no zeros, no roots, no zeros. So p is equal to 3, z is equal to 0, so n is equal to p greater 1 greater than z, so it is equal to 3. And also p minus z, that means the p minus z here it is 3 branches are approaching to infinity. So and poles located at s is equal to minus 1 and minus 2 plus or minus j2, two rows together. Now by using we have to find out angle of asymptotes theta. by using this formula, that is 2q plus 1 into 180 degree divided by p minus z. So p minus z is 3, we know, and q is, it starts from 0 and 1 and till p minus z minus 1. So p minus z is 3, minus 1 is 2. So q will be 0, 1, 2. So three asymptotes we will get. So that asymptote is also based on this p minus z poles and zeros, and also based on this q. So now we'll find out the angles. See, when q is equal to 0, you just substitute 0 here. It will be 180 degree divided by 3. You will get 60 degree. Just call this one as theta 1. When q is equal to 1, we call this one as theta 2. It is 2 into 1 plus 1 into 180 degree divided by 3. So 180 degree you will get. And q is equal to 2 theta 3 you write. And it is, if you substitute, you will get 300. Now we got angles of asymptotes, but where you have to draw these angles? For that we have to find out centroid. So centroid is sigma is equal to summation real parts of poles and real minus real part of zeros divided by p minus z. So number of roots we got, and real part of poles. See, real part of pole is minus 1 real part, and for other one it is minus 2 plus or minus j2. So minus 2 real part. Again 2 minus 2 we have to write because two roots are there here. One is minus 2 plus j2, minus 2 is the real part. Another one minus 2 minus j2, again minus 2 is the real part. So just write those two real parts here, minus 1 minus 2 minus 2 minus summation of real parts of zeros. So in this example there is no zeros only, so it is just substitute it as 0 divided by 3. See, you will get minus 5 divided by 3, so you will get minus 1.67. So that is centroid. So now we have to plot like this. In the x-axis we have to plot uh, poles and zeros. See, at 0 no pole, and minus 1 is the first pole at, and we have indicated by minus cross multiplication sign, and other poles is a complex one. It is minus 1 point, right? What minus no poles, yeah, minus 2. See, minus 2 will get a pole at minus 2 and plus j2, and minus 2 and minus j2 will get. See, now we got one pole at minus 1 and another pole at my complex one, minus 2 plus j2 and minus 2 minus j2, and there is no zeros. Okay, leave that one. And now we have to we got centroid, that is minus 1.67. Just mark by using scale. You have to identify where is minus 1.6, that is here. This is centroid. From here you have to draw three angles. Theta 1 is 60 degree, theta 2 is 180 degree, theta 3 is 300 degree. So this is theta 1, theta 2 and theta 3. See, this is theta 1 60 degree, and this is theta 2 180 degree, and the whole one is theta 3, and it is 300 degree. Straight line you draw and call that one as theta 1, here theta 2 and theta 3. So in this way we have to draw centroid and asymptotes. So the rule number 4 and 5 will give centroid and uh, angle of asymptotes. Thank you.